All right, hey guys, can you guys type in and let me know if anybody's there? Just gonna wait a second before we start going over this, but I would really like for us to just go over the checklist a little bit because people have been emailing me with a lot of questions, so there's a couple of things that I'd like to go into. So let's just see. Just trying to open up the stream here. Hey Brooke. All right, so I'm just gonna go in. You guys, hey Dennis, you guys could type me questions if you want to. I'm just gonna go over a couple of things quickly because people have been emailing me questions, like I was saying. So I don't think that we need to go over very much in the living world because I think you guys are good to go for this. So for living world, the main focus seems to be the digestive system because we have all of these points for digestive system. So you need to make sure you have a good understanding of digestive system, how the tract works, how the glands work, which glands are digesting, which type of nutrient. So that's important for you to be aware of. Okay, that's the main focus for living world. After that, at the bottom for living world, there's respiratory system. I can describe the function of nasal cavity and lungs. So that's really not too much for you to have to know for the respiratory. I still think it's important for you to understand that when volume increases, pressure decreases, because like I said, I have not seen the exam yet. They won't let me look at it. But I think that they're going to combine maybe a respiratory system question with your pressure and fluids question. To me, that's what makes the most sense for them to ask you on the exam. Okay? After that, you just have to know, I can determine the compatibility or incompatibility of blood types. So for circulatory system, you just have to be able to do blood types from what I understand. Lymphatic system, I can describe two ways of acquiring active immunity. So antibodies and vaccination are the two things that you need to be able to understand for your lymphatic system. And it would be a good idea for you to know that your antibodies are as a result of your white blood cells trying to fight off infections. Okay. Then excretory. So I'll just highlight that. So antibodies and vaccination are the two things you need to do here. Blood types here. Okay. Other than that, I can describe the function of the kidneys and the bladder. I think you guys can do that. So I'm not going to focus too much on that. Here we have, I can name the main components of urine. I can explain the role of the kidneys. So I think you guys are good to go for that. Then there's a little bit more emphasis on the nervous system. So you need to make sure you have a bit of an understanding of the nervous system. Small amount for musculoskeletal. But then afterwards, there's a lot of other things that you guys have been emailing me questions about. So in the last video, or the last live stream, if you watch it in a video now, we went over cell division. So we talked about mitosis and meiosis. It's important to remember that mitosis is the one for reproducing your cells, so making copies of the cell. It's for growth, for tissue regeneration if you injure yourself, and that those cells have 46 chromosomes. So when you make, like your regular cells have 46 chromosomes, when you make a copy during mitosis, you're making an exact copy. Okay, so other than that, I can distinguish between mitosis and meiosis. So meiosis is the one that's production of gametes of sex cells. Okay, thanks, John. Well, that's a great comment. Just moral support, love it. All right, so it's important for you to know for reproduction. It is only talking about here, I can name the hormones responsible for the formation of spermatozoa. So that's basically giving you the idea that the only question that they're going to ask you is about hormones and that they're focusing on the male hormones. So I summed up in our last one here that FSH and LH are for both male and female. They come from your pituitary gland. Okay, testosterone is the male. And then estrogen and progesterone are female hormones to do with ovulation and menstruation. So I think that what this will be a multiple choice question where it's asking you which one of these hormones doesn't match up with the formation of spermatozoa. So they'll put FSH, LH, testosterone, and then they'll put either estrogen or progesterone, and you're going to have to say that one doesn't match up. John's asking me, are you just reviewing the checklist? I'm just going to go over the checklist, and then there's another one that we did with one of the practice exams. Well, we've done a couple with practice exams. I'm just going to go over questions people have from the checklist. If you have any, you can type them in. Other than that, tomorrow we have our actual tutorial, 9 to 12 in 303. And I have another practice exam to go over with you guys during that. So it would be awesome if you guys can make it into that. But just if you have any questions, just type them right now and I'll go right to that part on the checklist. Brooke, this isn't really related to the checklist, but are you going to be correcting our exam? Yes, it's me that's correcting your final exams, okay? So I will be I won't actually be in your exam, like sitting in the room with you. There will be another teacher in there. But me and Mr. O'Brien are both designated as floaters for your exam. So that means that we get to walk back and forth between all of the classes that are doing science exams. So mainly it would be you guys, but if there's any other classes doing a science exam for other grades, we have to circulate to those too. So we'll come in and out for your questions. Kate is asking, can we go over the changes part of the checklist? Yeah, I'm going to for sure do the changes part. So let me just move on from this. I'm just going to skip quickly past that Earth and space section. You guys are aware why I'm skipping that. I'm going to I can go into the changes. Well, we'll just do this page together quickly. But yeah, I'm definitely going to go into detail about the changes. I highlighted these sections because I think that you guys probably would need to go over them. So it's important for you to know the characteristic properties. So there seems to be a focus on density here. It says I can explain the concept of density. So you need to be able to kind of like explain the whole, the question that we kept talking about in class was what's heavier, a pound of bricks or a pound of feathers? And we've decided that the answer is that they're both the same because they both weigh a pound. But you guys know that a brick is more dense than a feather. So you need to be able to explain that it's the mass over a certain area of space. So it's mass over volume, okay? So you're going to have to be able to calculate this. But this is going to be, if there's a calculator beside, that means you have to be able to calculate something. So this is showing you that you have to calculate. But the formula will be at the back of the exam. But it's density equals mass over volume. It says, I can identify a liquid and solid substance by their density using a reference document. So those are those practice questions that we've seen where they give you, they tell you there's an unknown, and they might give you the mass and volume of that unknown, and then like they ask you to match it up with the density, like with which one is actually the one they're talking about. So you'd have to calculate density and then say the ones that have the same density are the same, okay? Here it's talking about I can define the concept of solubility. So you need to remember that solubility is how much you can mix in of something before it won't mix in anymore. So like we talked about Kool-Aid and we talked about hot chocolate. At a certain point when you put too much powder in there, it won't actually mix into the liquid. It's just going to get clumpy. Okay, so that's the solubility, is the maximum amount of solute that you can mix into a solvent before it stops mixing. Okay, but here, Brooke is saying, how would you calculate solubility? You're not going to have to calculate solubility at all. You're just going to have to explain what it means. And then the only other thing they can ask you is this part here that says, I can describe the effect of variations in temperature on the solubility of a substance. We didn't talk about this a lot, but I'm writing it in your checklist for you here that if the temperature increases, the solubility increases. Okay, so that's important that it might ask you at some point on the exam, like what happens like at these two temperatures, which one would have a higher solubility? So when the temperature is higher, the solubility is higher as well. Okay, so you do not need to know how to calculate solubility. I don't even know how to tell you how to calculate solubility, to be honest, okay? Okay, so then in solutions, I hope everybody's okay for that. In solutions, it's talking about, this language was a little bit confusing, so I got emails from people on this saying, I can recognize the solute in a given aqueous solution, and I can recognize the solvent in a given aqueous solution. Aqueous solution, this is just talking like aqua, which means water, right? So it's any kind of water or liquid-based solution that they're going to give you. They want you to be able to define what's the solute and the solvent. So the solute is the part that's mixing in. So if our example is going to be Kool-Aid, then the solute, you'd have to be able to say that the solute is the powder and the solvent is the water. Okay, you have to just be able to do that. And then it says I can define the concept of concentration of a solution. So you would have to just be able to define that it's the strength of the solution. So the amount of solute per solvent. But then you need to be able to calculate it in grams per liter or with a percentage. So for grams per liter, you need to remember if one is in grams per liter, like if something, you need to be able to convert milliliters to liters. So that's something you need to be able to do. And you need to remember that if it's in a percentage, if it says like 5% mass over volume, okay, you need to remember that that is 5 grams over 100 milliliters. Okay, so anytime you see this percent, that means it's over 100 milliliters. So then remember that afterwards, if they're comparing one in grams per liter and one in percent mass over volume, that the one that's percent, it's not just like 5 grams per liter, it's 5 grams per 100 milliliters. Okay, John is saying, can you tell us what will be on the part B section, like the type of questions? Okay, so the type of questions in part B is when they're asking you to kind of like explain something. So I actually have another practice exam that we're going to go over tomorrow, and I can just show you the kinds of questions. So there's stuff that we did in our exam, like our mid-year exam. So here's one from like part B from the exam we're going to go over tomorrow. Is like they're showing you a picture of a dialysis treatment, and then they'll just ask you questions like this underneath. So if dialysis is required, which organ has lost function? So you'd have to be able to say that the organ that has lost function in the involvement of doing dialysis, you would have to say that it's your kidney. And you get either 1 mark or 0 marks for that. So either you get it right or wrong. And then down here it says, why is dialysis not necessary in a healthy individual? So you would have to explain underneath here. This one's out of 3 marks. You'd have to actually explain what your kidneys do and that your kidneys are filtering your blood and like taking toxins out of your blood, so that in a healthy person, you wouldn't need a machine to do this because your kidneys are doing it. And then someone who needs dialysis, when they're losing function in their kidneys, they need a machine to be able to filter their blood. Okay, so some kind of explanation of that, you can get part marks for these. All right, so that's the kind of question that we would have for part B. Okay, and this practice exam that I have right here, we haven't done this one yet, but that I'm going to give that to you guys if you come to the tutorial tomorrow. All right, so back to the checklist here. Now we're at the part that Kate was asking us about this to go over the changes part of the checklist. So we'll go into this. So changes, it's saying, I can define the particle model as a means of representing the behavior of matter. So basically, you just need to be able to explain what the particle model is, but it's just like a way that we've used of like explaining how liquid, solids, and gases work and how they react to things, okay? So it's just a concept that we use to explain this. I can represent a decomposition or synthesis reaction using the particle model. So I've gotten several emails and questions about this at tutorials at lunchtime and stuff like that. So I'll just do this underneath quickly. Okay, so because the next one is also saying I can associate the known chemical reactions with decomposition or synthesis reactions. Okay, so underneath here, I'll just use NaCl as my example. So if you have 2 basic pieces, so Na plus Cl, and we put these together to make NaCl. Okay, if you have some 2 simple going to something more complex, so simple to complex, this would be a synthesis. Okay, and the known chemical reaction that they're talking about for this, the example that they might ask you to be able to identify would be photosynthesis. But that one's pretty obvious, I feel like, because it has synthesis right in the word. So the only one I think that they could ask you for this, but they might just give you this. They might give you an equation of a couple of elements, and then like say that they're turning into something more complex, and now they've like formed something new that's complicated. Okay, so anytime you see basic pieces being put together into something more complex, that's a synthesis. Okay, a decomposition is the opposite of that. So decomposition, you would already have NaCl, and you would be breaking it down into different parts. So Na plus Cl. Now you have something, you go complex to simple. Okay, that would be a decomposition. Whoops. Okay, and the example that they could probably give you for this would be cellular respiration. All right, so that's what they're talking about when they're saying I can associate known chemical reactions with decomposition or synthesis reactions. These are the examples that they would be able to go over with, to be able to go with, for you to have to match up. But other than that, I think like they can't ask you really any other ones. And these were both in one of the other practice exams that I gave you guys. Okay, what else? So let me see. So that's okay. We did this. I can describe different forms of energy. So you just need to be able to define chemical energy, thermal energy, mechanical energy, and radiation. Okay, and they're not naming any other ones. So you just need to know the definitions of those 4 types of energy. And then it says, I can identify the forms of energy involved in a transformation. So, we talked about energy transfer and energy transformation at a certain point. So transfer is like if the heater's on and you get close to the heater and put your hands there, and then your hands get warm. So the heater's hot, and then it's transferring that energy to your body, and now you're warm as well. Okay, that would be a transfer. But a transformation would be like you have a fire and there's something, you're going to cook something on that fire. So if you cook a marshmallow on that fire, you're taking like thermal energy and you're transferring it, you're transforming it into chemical energy by burning something. Okay, and the thing that's actually burning, like that part would be like a chemical energy. Okay, so transformation, they'll give you an example. So if you know these 4 types up here, they'll give you some kind of scenario and they'll say like identify which 2 types of energy are involved here. Okay? So let me just see. So we're good for this. Okay, so Brooke is asking me, would you be able to give us examples of each type of energy mentioned on the checklist? Sure. Okay, so chemical energy could be like in your cells. Okay, so like all the chemical changes that we see happening inside the body. So this could be like in your cells or your body. Thermal energy could be like a fire. Mechanical energy could be any of the things we talked about in the tech unit. So like using physical force to be able to do something. So like when you any of the situations where you would have to do something, like if you turn a handle for something and then that energy is transferring over to like mechanics to be able to move something. So the physical energy that you would use for that is mechanical. And then radiation, an example for this, radiant energy would definitely be like electricity or anything that has to do with waves. Like we talked about radiant waves and everything like that in the wave section. Okay, so people are just typing the same questions about the different kinds of energy. Okay, so that's fine. We can go a little bit more into detail about those kinds of energy at the review session tomorrow, because I realized that we did them in the form of projects. So some people only studied certain kinds of energy. So we can talk about them tomorrow. Okay, So and then John saying like a bike. Yeah, so mechanical energy would be like using a bicycle. All right, so I'm just going to move on from this changes section here. So we did this and this. I highlighted waves, but I can go through this other stuff too quickly if you want to. Kayla's asking, for chemical energy, can it be the digestive system? So yes, there could be examples from the digestive system that are in the chemical energy questions. So like that your saliva is using chemical energy to break down starch. Okay, so yeah, that's a great example, and there's a good chance that they could use those examples since there is a heavy concentration on the digestive system as well. But your teeth, like chewing something, that's using mechanical energy because you're actually transforming in that situation. Like you're using the energy from your food, that's chemical energy that you're getting from your food when you're eating it. You transform that into mechanical energy to have enough energy to be able to chew your food. So your chewing would be like a mechanical energy. Okay? So, but I think you guys know which ones are mechanical and which ones are chemical when it comes to digestive system. We've talked about that a lot. All right, so I can go through this quickly, but it was waves that I wanted to talk to you guys about. But I can go through this other stuff quick. So you need to be able to talk about a pure substance, which is atoms and molecules. So you need to be able, it looks like they're just talking about elements and compounds here. Okay, so you need to be able to identify elements and compounds. These are both pure substances. Okay, something that is not a pure substance would be like your blood, for example, because your blood is actually a colloid, which is again a mixture where you have to look under a microscope to be able to see the different parts. But we know that in your blood you have white blood cells, red blood cells, platelets, and plasma. So all of those things together make up your blood. So that's actually a mixture. Like that's not a pure substance. A pure substance would be like hydrogen, so an atom of hydrogen, or H2O, which is a water molecule. Okay, so that's a molecule, this one. But like it's a compound. They're attached. You would have to actually do a chemical change to be able to chemical reaction to be able to separate the hydrogen from the oxygen. So they're like bound together. All right, those are pure substances. You need to be able to do compressible and incompressible fluids. So compressible is gas because you can squeeze it into a smaller space. Incompressible is liquid. All right, because you cannot squish a liquid into a smaller space than it can fit in. It's not like you can't compress it. Okay, and solids are not part of fluid. So you can name compressible fluids and incompressible fluids in the human body. So you would have to be able to name examples of that. So here in the human body, a compressible fluid would be like O2 or CO2. Okay, so those gases that we have inside our body, or an incompressible fluid would be blood. Okay, I can explain how fluids move around in the human body using the concept of pressure. So we did this on our most recent test about pressure and fluids. So you'd have to be able to explain, like I was saying when I was talking about in the living world part, that it is important for you to know. I think they will use the lungs as your example, that the gas exchange is happening because you increase the volume in your lungs, which decreases the pressure in your lungs, and then the particles rush in. So you'd have to be able to explain that using the concept of pressure. Or they could ask you about your blood pressure. Okay? I can qualitatively describe the relationship between the pressure and volume of gas. Okay, so that's all coming down to me. This, together with the question that was the checkpoint that was saying that you need to be able to describe the function of your nasal cavity and your lungs. Like I think all of this is going to be a question about when volume increases, pressure decreases. So I think they'll combine all of that into one question, and you'll have to explain how that works. Okay? A lot of people are having trouble with waves, so you have to be able to define the frequency of a wave. So the number of cycles per second is a hertz. Okay, so like you measure, like when it's talking about cycles, that's talking about wavelength, so which is mentioned down here. Okay, so you need to be able to say that frequency is a number of cycles per second, and we measure it in hertz, and that when they're talking about a cycle, they're talking about a wavelength. Okay, so it's a distance between two identical points on a wave at any given time. The only other thing that we need to check out here is that I can associate the frequency of a sound wave with the pitch of the sound. So if there's a higher frequency, then it's a higher pitched noise. Okay, so low frequencies are low pitched sounds, high frequencies are high pitched sounds. Okay, so you need to be able to understand that. I think that what they'll do is they'll give you two waves and they'll say which one of these has a higher frequency and which one has a higher pitch, and it's the same answer. Okay, so then I can describe the relationship between wavelength and energy. I can locate different areas on the electromagnetic spectrum. Okay, so just remember the electromagnetic spectrum we've looked at several times. So you would have to be able to say like which areas are stronger waves and which ones are weaker. So it goes from radio waves, which is weak, all the way to gamma, which is really strong. And I think they might ask you like which one of these is stronger on here. There's a chance they could ask you which one of these is involved with, like give an example of how these can be used in the healthcare system. So you guys know that X-ray is on there, so you could use X-ray. You could use radio waves are used in MRI machines. You could also use that gamma rays are used for radiation treatment for cancer patients. Okay, so all of those are examples of how those things are used in the human body. Down here, when it's talking about, I can determine the focal point of concave and convex lenses. Okay, I think that what it's saying here, I can describe the relationship between the focal point of a lens and the degree of the deviation of light rays in a different situation. I think that they're going to ask you a question about your eye. Okay, and so concave and convex lenses, you need to be able to tell the difference between those two images. So this would be like the ones that are caved towards each other. This would be two lenses that are caved away from each other. Okay, you need to understand that, and then understand which ones are used in correction of which type of like focal point of a lens. Okay, so like you need to, if they show you a picture, I'm just gonna draw my really bad picture of an eye down here. Okay, and your lens is in here. Your focal point is supposed to be back here on your retina. Okay, and like sometimes, because it's supposed to go in here and meet up at a focal point inside your eye. Okay, your lens is refracting. Okay, so this is refracting the light onto the focal point at the back of your eye. Sometimes people's focal point is messed up and ends up either here or back here, which causes myopia or hyperopia. Okay, and there's different kinds of lenses for correcting that, so you have to be able to explain that. Okay, John is saying for part C, there's 4 questions. Can you do 3 questions only like the midterm exam? Okay, no, on the midterm exam, I didn't do a tech section. Like we did a different kind of exam, okay? I didn't do a tech section because we hadn't learned about tech yet. But for your final exam, it's not, part C is not long answer questions like you have in history and math. It's a tech question. So they give you some kind of tech object, and then they ask you a series of questions about that tech object. Okay, so they're not actually long answer questions. The most writing you have to do is in part B, like in those questions where I said you have to explain things. Part C is asking you more like they ask you, they'll give you an object and they'll point to a certain part of the object and they'll say, is this like guiding, linking, lubricating, or sealing? And you have to choose which, like out of those 4 things. So your answer is just one of those 4 things. So that'll be a question. Then there'll be a question where they'll be talking about like what kind of material is the best one to use to build this. And then that's the only case where you have to like write a paragraph. Like they'll give you the densities, they'll give you a couple of other things like whether it's malleable or what, and they'll tell you, like, you have to argue why you would choose that material to build that object. Okay? Are there any questions for the checklist for Tech World? Because I feel like this has been our most recent topic, and we went over this quite a bit in class when we were doing the Part C of the exam. Like, I gave you guys a summary of all of this stuff, and I handed that out in class. So I can give you guys, if anybody's missing a copy of that, I can give you a copy of that tomorrow too. But are there any questions from from the Tech World here, or should I just stop now? So type right away if you have any questions. Because otherwise I'm just going to cut this short and we can go over, like, I want you guys to study on your own, rest up a little bit. We can do 3 hours, like, in-class tutorial tomorrow from 9 to 12. And then other than that, we will do one more review tomorrow night. And you guys can ask any other things or whatever you're freaking out about. Okay, Brooke is saying, can you go over transmission and transformation systems? Sure. So let me just find where they're talking about that on here. Components of use of transmission system. Okay, so when you have a transmission system, you're staying in the same, I'll just move it a little bit this way so I can write on the side. Okay, so you always have same type of motion. Okay, so out of the types of motion, what I'm talking about is, like, if it's rotating, then afterwards it's still rotating. So they tell you what they are in here. You need to know these ones. So you need to know friction gears, pulleys and belts, gear assembly, sprocket wheels and chain, wheel and worm gear. Okay, so we talked about all of these things. I didn't use exactly the same words as this in class. I used the words that were in your textbook, but it's all of the ones that we just did on our most recent tech test. You need to be able to identify those. So, like, you know that a gear is, you have two wheels, but a gear, like, if they're just wheels without any teeth on them, those will be friction wheels, or I guess they're calling it friction gears, but, like, in this case, like, a gear system would be the one that has teeth on it. Okay, and you need to be able to like explain. This says I can describe the function of the components of a motion transmission system. So you need to be able to explain that, like, if this is moving this way, the teeth are catching into here, and this one's moving that way. Okay, you would need to be able to explain how they work in relation to each other. I can describe the speed changes of reversibility of a motion transmission system. So you would need to be able to explain that when you're transferring from a large gear to a small gear, okay, or whatever, if there's, so larger gear moves slower than a smaller gear. Okay, so if you're transferring to the large gear, like in a car, if you're on the smaller gear, it's going faster. If you're on a larger gear, it's going slower. Okay, and so it has to do with the size of the gear, but it could also, they could ask you to do with number of teeth. Okay, so if there's more teeth, it's going slower. All right. So John's saying, can you stop now and we'll do it tomorrow? And then he's asking gear assembly. So gear assembly is just like a set of gears. Okay, I'm just going to finish going over this transformation part that Brooke asked me to go over, and then we'll stop and go over the rest in class tomorrow. Okay? I can name motion transformation system in a tech object. So this one is a little bit different because it's going from, like, it's doing a change in type of motion. So that means if you started out as doing a rotation, the second object or second component of the object is not doing rotation anymore. It's doing, like, translation. Wow, can't fit this on here. Don't want to write on my table. Okay, so this would be like something that's turning, and then the other component is either going left to right or up and down. Okay, so it's changing it's like changing what the motion is. Okay, so I can name motion transformation systems and technical objects. I can describe the function of the components of a motion transformation system. I can describe speed changes or reversibility of a motion. Okay, so in these ones, we have camera follower. We have rack and pinion. We have screw and nut. And then rod and crank. Those are the four that you need to understand. So you need to be able to explain what those are, and like they'll just give you pictures from what I'm understanding, like in the tech part. They'll give you a picture and they'll like focus in on a certain area and circle what's happening, and they'll say what kind of transformation system is this, and you'll have to name one of these four systems, okay? And like what the different components are doing within there. So you have to explain which parts are like turning, which parts are moving up and down or left to right, and how that works, okay? All right, so Alicia is asking me what's an isometric projection. So isometric projections, when they're talking about that, isometric projection is like a picture, like, you know, when it was talking about top view, side view, front view, so the multi-view system that we talked about. So an isometric projection is like they would have kind of a 3D image, and then afterwards you have to be able to relate to drawing it in like from the different views. So we've done practices of that in class where it was like they gave you some kind of object in 3D, and then out of the 4 multiple choice, it'll say like which one of these matches with the right kinds of views. So they'll show you the top view, front view, side view, and 3 of them won't match up, and 1 of them will be the right one. John's saying, do you need to know that? Yeah, you need to be able to do that. I think there's going to be a multiple choice question like that. Okay, so if nobody has any other questions, I'm going to cut this off because it's almost 9 o'clock, and we will pick it up at 9 a.m. tomorrow. Brooke is saying, do you think they will give us a question where we need to draw an isometric view? No, I don't think you're going to have to draw anything. I think that they're going to show you drawings, and you're going to have to choose which one actually matches up properly. Okay, I don't think you're going to have to draw anything. John's asking me to do a face reveal. No way, John. I'm a total mess. Face reveal in class tomorrow. You have to actually show up to see my face. All right, have a good night, you guys. I'll see you tomorrow. Don't forget, 9 o'clock in room 303. If for whatever reason you want to show up later, or you want to stay for a little while and you don't want to stay the whole time, like, don't worry about it. It's not a class, it's a tutorial. You can come and go as you would like. I think it's probably in your best interest to show up, but at that point it's on you. So you decide if you're coming or not. Exam is on Tuesday at 9 a.m. All right? Have a good night.